Welcome back to the channel. For today we have a Wells Gardner U2000 25-inch, and this is the third chassis in the series of 4 that I recently got from a local operator who somebody he knew found them and said, here, you can have them, I don't want them. And then the operator contacted me and said, here, I don't want them, you can have them. So yep, here it is. The first two were the 19-inch K7000s, the 7000, I think it was the A and B and C, I forget. It's been too long. I've been working on a Simpsons machine restoration, so I can't recall exactly. I'm too lazy to go look it up firsthand. So, but we had the two 19-inch K7000s prior to this one. Those are 1 and 2. This will be 3, and the fourth one is a K7500. I'll get to after this one. But for this video, we have a U2000 25-inch. I have not taken it out of the bag. This has been in this bag on a shelf somewhere since 2007, March 5th, 2007. It says, came from gun game at Playmore, whatever that means. So, yeah, let's take it out and take a look at it. It says, did it say anything? It says good. I don't know if caps are original. I don't know if it's been reworked. I have no idea. Okay, looks like someone just cut it out of a game because they cut the ground wire, the dag wire. They I don't know why they would do that, but they cut the yoke wires for the vertical. They cut the yoke wires for the horizontal, and the linearity coil is destroyed. This has to be, I mean, the chassis would work in this condition, but you'd have very weird horizontal linearity. I think this is horizontal linearity. But you'd have very weird linearity issues with the coil like this because you have to have that magnet in place properly. If that magnet's not in place properly, it can affect your linearity. So this has to be, okay, that's good there. I'll have to glue it back in place, but that's more like how it should be. So that is fixed for the moment. But yeah, they just completely cut the whole thing out. And caps have been replaced. You can tell because there's no glue on this cap and there's no glue on this cap. So at least some of them, if not all of them, have been replaced. So that's good at least. This U2000 has the vertical sweep mod. Wait a minute, why does the U2000 have the vertical sweep mod and the U5000? This is a U5000 decal. This is a decal that's on the U5000 frame of the tube to make sure you have this set correctly for your resolution setting. This is a U5000 mod. Why is it on the U2000? I think I'll have to do some research. I think, oh, and someone has replaced the shutdown pot with one like this. This is odd. So, yep, looks like someone has definitely done some work to this. It has seen high usage because the C725 here is completely covered in dirt. So it's a high usage chassis, but this is very peculiar. I can't say I've ever seen a U2000 with the U5000 vertical sweep mod. I think there actually is an official service bulletin from Wells Gardner that documents this vertical sweep mod to do on these chassis. Not just the U2000, but the 7400 and 7500. But as far as my recollection goes, this is something that's only used on the U5000 because you can't select the operation. It says 25 kilohertz operation, which is medium res, and then it has the 15 kilohertz operation, there it is, for the standard resolution. And what you're supposed to do is, you can see how this jumper wire here, this white wire, is represented by this wire right here. And you can see that it's supposed to be hooked up to the jumper for 15 kilohertz, and it's not supposed to be hooked up for 25. But this is only a 15 kilohertz chassis. It's not capable of doing 25, so I have no idea why this is here, and I have no idea why the sweep mod is installed. But we want to make sure that it's actually hooked up, and they weren't even hooked up right. They had the black wire here, they had the black wire part with no wire coming out of it plugged into the pin. So we'll move it back over to the side with the white stripe, or the white stripe, the white wire, because that's how it's supposed to be hooked up for the mod to actually function properly. There we go. So that's how it should be for 15 kilohertz standard resolution operation. It should be, the white wire should be plugged onto the pin. But I don't know why this is here. I've never seen a U2000 with this mod before. So you can correct me out there if you've seen it before, or know what it's, or know, I know what it does. It's for the vertical sweep functionality to improve it. But I've never seen it installed on a U2000. I've only ever seen it on the 5000. And this sticker here, it shouldn't even be here for the 2000 because you can't select the resolution. Anyway, that's very odd, but we'll keep going here. Someone has definitely done the rework with the replacing the shutdown pod and putting the sweep mod on there and doing the cap kit. So it looks like Q703 has been replaced as well because it's kind of hanging out in no man's land there. We'll take that off of there. And it's obviously very dirty, but it looks to be complete, and they've got it marked as working. So we'll still go through and check everything to make sure. Let's check out the back side. Oh, even the degauss cable they cut off. That's unfortunate. Back side is relatively clean. I don't see any butchering except for around here at the. Someone has replaced or worked on the voltage regulator. This guy right here is the voltage regulator, and it looks like somebody. Wow, they cut the original one out and installed a replacement, but they just soldered right to the legs. Instead of removing the legs and doing it properly, like they pulled this out of another chassis that was installed as a through hole. This was a through hole transistor. They took it out and just soldered to the legs of the old one, or installed some jumper legs. Plus it's missing the... This is supposed to be much lower, this is supposed to be a through hole installation, and there's supposed to be a little riser that sits on top of there, and the screw goes through the riser, and the riser holds the transistor against the heatsink, and this sits much lower. I don't know if they messed that up or what, but this is very interesting. I mean, I could leave it if it's. I mean, if it works, it's fine. I can leave it, but it's a very odd way of doing it. But this came from an operator stash, so. You know, you got to get those games up and going as fast as possible. So that's very odd. Let's go back to the back here. Okay. So we had the voltage regulator kind of weird stuff going on there. We got some oxidized pads over here on this side. Yeah, general cap kit worked. It doesn't look like it was done too badly. So I think someone changed the coil here because the old pads are removed, and they've moved it down one. I think they changed out, and there's flux on these pads. Yeah, someone definitely replaced this coil, L101, and they just moved it down one. I must have got a different type, or I don't know, but you can install it two different ways. So that's been changed. There's been some work done on the HOT. So this has been reworked, but it's marked as working. So without really doing anything, let's do our testing so we can actually show you what to test on these, a little refresher course. And then we'll power it up just the way that it is and see if it's working. If it is, then I'll go through and do the solder reflow and everything else off camera because there's no real reason to do any of that on camera, just make the video longer. So we'll do all of our testing. If everything checks out, I will do my repair on the linearity coil, and I will do all my reflow work and inspection and anything that else needs done to it, and I'll probably clean it off as well, and then put it back as a replacement U2000 if something goes bad at the business. So this will be added to the collection of spare chassis that I'm going to have on the shelf to replace ones that go bad at the business. So, all right, let's go ahead and start our testing here. Okay, we'll go to ohms, and again, you know what I'm going to do? We didn't inspect the neck board yet, but we'll do that in a minute after I do this here. Oh, Man. Jeez. It's the toughest one I ever took off. Let's get rid of that and the neck board. Alright, so those aren't in our way. I got a free connector out of the deal too. Nice. Okay, so a little refresher here. We got a 10K ohm. What is this? R104, is it? Yep, R104. Should be 10K ohm. Now, if this reads 10K ohm, everything here in this side should be good. If it's not, then either the resistor's bad or something's bad in this circuit here. So let's check it, make sure it's 10K. Perfect. 11K, that's fine though. So we don't really got to worry about anything in here, but we'll check the voltage regulator anyway. So we go to diode mode, and our voltage regulator should be these three pads. I think one side should be 1 point something or other. There we go, 1.0, so that was correct. And I think this side should be the 0.5 voltage drop. Yep, perfect. So voltage regulator is good. You know, as many of these as I've done, sometimes I forget, you know, so I got to do a little refresher on my own. So we know that our voltage regulator and our main resistor over here is good, so this should all be okay. Let's check our switch mode power supply. I believe we should have a voltage drop diode across these. There's 4 pins on each side here. There's this row and this row. I think these two should be the voltage drop diode. These two should be a voltage drop diode. This should be like 1.0. This should be 1.8. I'm trying to go off memory here, but let's make sure we're getting a good reading on these. So this should be the voltage drop. Correct, 0.6. This should be the voltage drop. 0.6. I think this is 1.0. 1.1, that's good, and then 1.8. Yep, outstanding. So switch mode power supply should be good. Right. Yeah, we can check our HOT. 0.5 on one to the other. 0.45 and 0.45. HOT is good. We can check our D603. This guy in here for the, I'll show you here. D603 is this guy here. This is for our vertical IC. If it reads both ways, our vertical IC is bad. If it reads one way, the way a diode should read, then the vertical IC should be good. So if we zoom back out here and we go to our D603, there's our voltage drop, so that's good. If I swap my leads around, it should not read, should not give me a reading. And it does not. So our vertical IC it should be good in theory. Oh, pardon me. Should be good in theory. We can check our R303. R303 is this resistor here. If this resistor is bad or out of tolerance, we'll have vertical collapse. So we want to make sure that is good. We'll go back to ohms. It should be around 2.5 or 3 ohms. Or is it? I think it's 3 ohms. I think it's 3 ohms. 1.5, yeah, I'm wrong. 1.5, 1.2. Yep, so that's good. I thought it was 3, but I think it depends on which chassis, 7400, 7500, U5000, something. But if you get a reading of 3 ohms, you're good. But we're 1.5, so that's good. So we should not have vertical collapse. That should be good. So I think I can safely say that this should power up. There's one more component, Q603. If Q603, this guy here, is dead or bad, the board will be completely, totally, 100% dead. No signs of life, no ticking, no nothing if Q603 is not good. So we can test that. Go back to our diode setting. And we'll go to 0.6 and 1.2, so that's good. Actually, I think what we need to do, I think the base is actually on this side. One of these sizes. There we go. 0.7 and Hell, I don't know. There's NPN transistors and PNP transistors, and some that are center based, some that are based on the left side, some that are based on the right side. And I've never taken the time to memorize which ones are NPN or PNP and the way it is. I always just put the negative on the center and go to each outside leg, 0.6 and 1.2. So that's a good reading for Q603. You're just checking to make sure that it's not shorted. You know, it's either going to be open or shorted. You're going to just checking to make sure that it's not shorted and that it's not open. If you get a reading on it, it's most likely okay. But you're always going to want to make sure, the way a transistor works is there's a diode inside of there that does the voltage drop that activates or deactivates the transistor functionality. And you just want to make sure you're reading that voltage drop. So there's the 0.6. So that should indicate a good transistor. If we go to the other leg, yeah, see 1.2. So that's they have a collector and an emitter. And yeah, so that's good. I'm not worried about that. I just still find this very fascinating. I've never seen a U2000 with a U5000 type of setup here. But I'm going to glue the linearity coil back in place here. And it should be okay. Where's my glue? There we go. Is it even loose here? Let's add this. And create a nice new hole there. Alright. Let's get this sucker glued back in here. Did this all dry out? What's going on here? Why? Oh, come on. It's not. There's some in there left. Get down there, you rascal. There you go. Nothing is ever easy. Let's try this again here. Well, I'm having issues. I'll do it off camera. I tried to do it now, but it ain't working. I got a bad glue bottle there, so let me I'll get it done off camera, but let's, now that we got everything tested, let's take a look at the neck board. And these aren't loose, but they're all smashed over, so we may have to correct that. Where's my cutters? There they are. Yep, definitely high life, high mileage chassis, because you can already see that the board is burned from the heat from these things. So just a bad design overall. Yeah, actually not too bad. They're lifted, but not severely bad enough to where a lot of rework needs done. So the first thing we'll do is I'll just take this and kind of bend this away so it's flat. There we go. Same thing with this one. I'm sorry about that. You kind of want to finesse these to where they're flat and they're not, you don't really want them resting against your, there's a little inductor here. These little blue things are inductors and these are resistors. You kind of want them to not be touching the heat sinks. But there we have straightened them back out, so that's good. And while we're here, yep, someone has already set all of our pots to center. I didn't do that, so that's something I always like to do, just to get a baseline for colors. And on the back side, this one here, they're pretty much intact. I shouldn't really have to do much to these. This one's intact and this one's intact. The only lifted pad is this one here, but it is secure. Someone has scraped away the trace and soldered to it. So yeah, they're not loose. They're intact. I think they'll probably be okay. And we could use some reflow on the resistors here for the color resistors, but for testing purposes, I'll spread them out so they don't induce heat on each other. And there we go. And yeah, it definitely needs some reflow work. There's some oxidation and everything here on some of the pads for them. So, but for testing purposes, it should be okay. Like I say, we'll get this now that we've got everything tested and it looks okay. Let's get this on a tube and test it. And assuming it looks good, we can get it set properly. I'll fix my coil and do reflow work and everything to get it all nice and fresh and refreshed off camera. But for the testing purposes, that's all this is really going to be for, is overview and testing. So let's get it all set back up and get a tube and turn it on and see what we get. Actually, before I do that, I forgot to mention it's always a good idea. I always do it, but for some reason I forgot to include it in that first part there before I cut away. It's always a good idea to make sure you don't have any broken pots before you power this up, because if you got a broken vertical size pot or broken horizontal position, you can have collapse or it can cause damage. So we want to make sure that in the process of this thing being removed or messed with or shipped or handed off or what have you, that we don't have any broken pots. It's very important to do that. So we'll check this out and make sure we don't have any broken pots, and everything looks good. I don't see any broken pieces, so that's good. Same thing with your color pots. You won't damage your chassis with the color pots if they're broken, but you might necessarily not have all your colors. So these all appear to be okay as well. I don't see any broken ones on the neck board. So it's important to verify that before powering up the chassis. And I forgot to mention that, and I'm glad I recalled it. I was going to hook this back up. I'm like, oh, I should probably talk about the pots. So, yep. All right, now let's get it hooked up and see what happens. All right, so we're all set up, ready to go. We got anode, neck, yoke, ground, video, remote board, power, and video. Did I say video already? I think I already said video. But anyway, we're all hooked back up. Neck board's all re-secure, and everything's hooked back up to it. I have not turned it on yet. I want you to share the knowledge with me of what happens if we have arcing and sparking, or if we have dead, if it works. Hey, we'll find out together in this journey. But I do want to mention this is a Henrix Polo tube. The Henrix Polo tube is absolutely compatible with all these Wells Gardner chassis. K7000, U2000, K7400, U5000, standard res only. I haven't tested it with the medium res, but the U5000 is kind of a magical creature where it kind of works on medium res with standard res yoke, but I haven't done a testing with the medium res setting on the 5000, just the standard res. But it takes a little retrofitting to get it to work. This is just a temporary setup where I have to cut the yoke wires and hook them up to the correct type of connection here for the Wells Gardner stuff. And that's why this plate's different and all that jazz. But so yeah, the Henrix Polo tube is absolutely compatible with the K7000, 7400, U2000, U5000 on standard res, and the Polo, of course, and the universal chassis, the 25-inch universal chassis you see on eBay for $100, whatever it is. That's compatible with this as well. So yeah, I'm using the Henrix Polo tube. It's all I have on hand to test this stuff with. So anyway, yep, it is ready to go. So let's get the camera on the tripod here and see what kind of magic we can make happen. Alright, so here we go. 1, 2, 3. Power right up. My linearity coil is still kind of bent, but it should be okay. Do we have anything? It's probably going to take a while, or I don't know what the settings are. Well, we do have an image. Of course, it's not good because nothing is set right. It's NBA Jam. So let's do brightness and contrast completely, totally down. Turn our flyback up. We're not going to get raster lines, but we'll turn it up to roughly, I'll say there. And then we'll turn our brightness. We're way overdriven on the red. Brightness is going to be roughly there. Contrast. Yeah, we're like all red. Let's do our H position. Perfect. Vertical position. Good. We got height. Sorry about that. I had a phone call. So, okay, back to where we were. Everything still is the same. So let's see if we can get this looking better. It's possible that I'm missing green. It looks like I'm missing green. So if we go into our test menu here, diagnostic tests, monitor patterns, we got red, and then no green, and blue. So we're missing our green. Very interesting. The red is heating up. The blue is heating up. The green is not. Well, it's working, but I think we have a dead green neck transistor, which is probably why this got taken off the tube it was on. And you can, obviously there's no green. I overlooked that just until just now. But we have no green. Yep. Otherwise, it's not a bad picture. It's super crisp and clear. And it seems to be filling the whole screen, and it's operational. So let's see if we can figure out why we have no green. Crisp, I tell you. So I let the monitor run for about 10 minutes off camera, and the red transistor got nice and hot. The blue transistor got nice and hot. This one was ice cold. So we're 100% certain that our actual transistor is dead. But let's say, for instance, this was getting warm and it wasn't the transistor. We still had no green, or really any color at all. Let's see here. There could be any number of problems on the neck board that would cause no color. So we'll just go through them all. Obviously you'd have one of your transistors as being bad, but let's say that they're all warming up and it's not a transistor. You can have any of these three transistors here be bad. 1, 2, 3. If one of these three are bad, you'll have a missing color on the associated transistor, so those could be bad. You could have any of your coils bad. This one, or this one. Those three coils could be bad. Any of these three transistors could be bad. You could have these three diodes in here. This diode, that diode, or that diode in there could be bad. Did I mention these three? Any of these three resistors? So you have these three resistors, these three coils, these three transistors, your main transistors. You could have a broken or open color pot. And last but not least, you could have a problem with your chip here. The U5000 chip controls your color and RGB as well. So you could have any number of problems on the neck board that can cause color issues. But in our case, let me go back. You should check all, if it's not any of the three main transistors, you want to check all those components. Lastly, it could be U500. But I've had missing colors that were caused by one of these, by one of these three, by one of these three coils, by one of these three diodes, by one of these three resistors. I mean, it could be any number of things. I've had one be with a broken pot. The whole gambit of problems I've had, at least one be the cause of no color. But in this case, with this not warming up and being ice cold while these are hot, we can almost guarantee 100% that that's the problem. So let's yank it out of there. And I guess before we can test it, I'll show you, it actually tests the same as the other ones. If we look here, we can test it. If we go to diode mode, and we go, I think one leg should be 0.6 and the other leg should be open. There's our 0.6, and then the other leg is open. That one's good. So if we go to the red one, there's our 0.6, and the other leg is open. The green one that's not heating up, 0.6, and the other leg is open. So it's reading the same as the other ones, but you can't always trust it. So we're going to pull it out of circuit and test it out of circuit, and I'll bet you that it's open. So the first thing we'll do is yank this out of here. I have the desoldering station, but sometimes it's just quicker and easier to use the braid. In my opinion. All right, and we should be out. So let's test our transistor out of circuit and see what we get. Center leg open, 0.6. So it's reading good, but it's not heating up. So what we're going to do is we're going to swap it. We're going to take out this one, put it in the green spot, and put the green one in that spot. I don't know if it's, I think it's RGB. It could be RGB, but regardless, we're going to take out this one and put it in this spot, and put this one in that spot, and see if we get our green back and lose our blue or red, I guess it is. That will tell us definitively. I mean, I could go through and test all of the other components, but the fact of this not heating up is almost, you know, it couldn't be any of the other components because the transistor is not running. So, in theory, I should say, in theory, in practical application, we're about to find out. Okay. Right out. I guess we can leave the heatsink off for now. Well, now let's put it back on. We're kind of crush it down here. Okay. We got that one in. Let's put this one in. Oh, come on. There we go. Okay. Get out of the way. Okie dokie. Now that that's all done, let's see if we gain our green and lose blue. I think that's what it is. I think it's, well, yeah, RG, red bias, green bias, blue bias, red, green, blue. So I'll bet you, let's see if we gain our green and lose our blue. If we do, we know 100% it's the transistor, even though it checked good in circuit and out of circuit. It's not always something you can rely on. So let's see what happens. All right, here we go. Let's see what happens. Power on. And there's our green. How about that? And we're missing blue. If we go into our test menu, can I accomplish this? There we go. Diagnostic test. Monitor patterns. Red, green, no blue. So there we go. Pretty definitive. I mean, I knew from just the fact that it wasn't heating up, I knew it was bad. But what was odd is that it reads good in circuit, exactly the same as the other two working ones. It reads good out of circuit, but it's still bad. So you can't always go off of the reading in circuit. That's why it's very important to pull the part out of the board that you suspect is bad and check it out of circuit and in circuit. But the flip side to that coin is the fact that it's still checked good in and out of circuit, but we knew it wasn't working because it wasn't heating up. So they're very definitive proof here. So let's get that replaced and get all of our colors back and call this one good. Okay, so I got a brand new transistor installed in the blue location. We originally swapped the blue to the green to get our green back to verify the green one was bad. I got a brand new one in the blue, so now we should have RGB, all three colors. Everything is hooked up, ready to go. I haven't checked it yet. I want you to share the knowledge with me, so here we go. 1, 2, 3. Okay, powered right on. Do we have blue? Or more importantly, do we have all of our colors? Well, it looks like we do. Let's get the camera set up so I don't have to hold it. And we'll do some testing here. We got an adjuster. There we go. And oh yeah, hit the button. Outstanding, and there you go, RGB. Let's go in the test menu. red, green, blue. Hot diggity. Of course, colors need adjusted a bit, but being set to center, we have a nice, good image. Nice, sharp, and crystal clear, and all of our colors, and we're good to go. So I'll call it a success. Thanks for watching. Hopefully you learned something. I still need to go through and do all the reflow and the more detailed inspection and a couple of other things, and clean it up, get it cleaned. But yeah, I think this was shelved because it lost green, and the person didn't know how to repair it, but who knows. It's been sitting on a shelf, I can assume, since 2007, so what is that, 14 years? So I got 3 of these chassis have been sitting on a shelf for 14, 18, and 27 years. In theory, I can't prove that, but I think that's what the case is. So anyway, the next one on the next video coming up on the list will be the final chassis of the 4 that I just recently got. With this being number 3, the 4th one is a K7500, and I believe it's 27-inch. So that'll be fun to try and get going. So stay tuned for that. Thanks for watching this video. Hopefully you learned something, and we'll see you on the next repair.